Welcome back. Today we're going to solve linear systems algebraically with elimination. So far we've solved them using graphing and substitution. Elimination is the easiest when the equations are in standard form. So the first step is to write the equation in standard form, which is ax plus by equals c. Now, when we identify a variable to eliminate, we're looking for coefficients with common factors. And we'll look at some of those examples. We're going to add and subtract the equations to isolate a variable. So we'll either get x equals something or y equals something. And then we're going to have to substitute that variable back in to get the next variable. So if we have the x, we'll have to plug that in to get the y, and vice versa. And then to check the equation or check the solutions, you can plug those values back into the equation and make sure your answer works. Okay, let's look at the first example. So here you may already see that the equations are in standard form. When we look at the coefficients, remember, if there's no number in front, it's a 1. So we have 1 and 3 for the x's, and then 1 and -1. If you notice, these have more in common than the other two. So if we add those two equations, essentially those y's are going to cancel out. And that is why we have elimination. So I'm just going to write them again. We already have them written up here, but they're already in standard form. And then when we add them, we're going to get 4x, because 1x plus 3x equals 4x. The y minus y is eliminated, equals 12. We're going to divide by 4 for both sides, and we'll get x equals 3. Now we want to substitute that value back into one of the equations so that we can get y. And remember, we had x plus y equals 5, so you could probably tell really quickly 3 plus y equals 5, so y must equal 2. And we're going to plug that back into the second equation, which was 3x minus y equals 7. Remember, we got x equals 3 and y equals 2. So 3 times 3 minus 2 equals 9 minus 2, which equals 7. So our final answer is going to be an ordered pair, 3, 2. Now let's go to the next one. For this one, we have 4x plus y equals 7 and 4x minus 2y equals -2. Now, you can see that the x's are very similar, right? They're exactly the same, 4x and 4x. If we add them, we'll get 8x. But if we subtract the second line, so I'll write the first line exactly the same, but for the next line, I'm going to multiply everything by -1, which is essentially subtracting. So I'll get -4x plus 2y equals +2. And we're going to add those so that the x's will be eliminated. So we'll have 4x minus 4x goes away. We'll have 3y equals 9. Divide both sides by 3, and we'll get y equals 3. Now we're going to plug 3 back into one of the equations. We have 4x plus 3 equals 7, just looking at the first one. When we solve for x, we'll get 4x equals 4, and x equals 1. So now that we know that x equals 1 and y equals 3, we can plug that into the equation. The second one, which was, I'll use a different color here, was 4x minus 2y equals -2. So we know that x equals 1 we knew that we got y equals 3. And we're just checking our answers. So 4 minus 6 does equal -2. So our final answer, remember we have to write the x first. It's going to be 1, 3. Now let's look at another example. When we look at the coefficients, we have 3y and -3y. So if we add those together, we'll eliminate the y. So we'll get 3x equals 15, or x equals 5. Now we can plug that into one of the equations. So x plus 3y equals 17. 5 plus 3 times y equals 17. We'll get 3y equals 12 when we subtract 5 from both sides, or y equals 4. So x equals 5, y equals 4. And our equation let me go back over here, was 2x minus 3y equals -2. So let me put that down here. So x equals 5, so 2 times 5, minus 3 times 4. 10 minus 12 does indeed equal -2. Okay, for the next example. Here you may notice we're starting to get a little tricky. The equations are not written in standard form. So I have 2x plus y equals 7. And you can notice that this y is the same as y over here. They both have coefficients of 1. So what I'm going to do is multiply this second equation by -1. So we have -4x minus y equals -5. When we add them together, we'll get -2x equals 2, so x equals -1. Now we can plug that back into one of the equations. I'll plug it into the first one. 2x plus y equals 7. 2 times -1 plus y. So I'll get -2. And then when I add 2 to both sides, I'll get y equals 9. Now to check my equations, I have y equals -4, x equals -4, and y equals 9. And I'm going to plug that into the second equation. 4x plus y equals 5. So 4 times -1 plus 9, well, that's going to be -4 plus 9, which equals 5. So our final answer here is -1, 9. And we always want to make sure we write the ordered pair, the coordinates they're going to intersect. Okay, for the next example. Okay, for this one, they look very similar. It's already in standard form. So 2x plus 2y equals 6. And what we need to make sure we do is to make sure something cancels, we're going to have to multiply that second equation by 2. So we get 6 times x minus 2y equals 10. Notice we're multiplying every single thing here by 2, even on the other side of the equality. All right, so now let's add them together. So we get 8x equals 16. Notice the y's were now eliminated. So we have x equals 2 when we divide both sides by 8. Now I'm going to plug that into one of the equations. I'll use the first one. So when we plug that in, it's going to be 2 times 2 plus 2 times y equals 6. 4 plus 2y equals 6. Subtract 2 from both sides, we'll get 2, and y equals 1. Now we need to make sure we plug that into the second equation, which was 3x minus y equals 5. Remember, our x was 2, our y was 1, and 6 minus 1 does equal 5. So our answer is going to be 2, 1. Now let's go to the next example. All right, for this one, you may notice that we have very similar coefficients, but they're in different orders, right? So this one has 3 times x and 4 times x. This has 4 times y and 3 times y. So what we're going to need to do to eliminate the variables, remember they have to have opposite numbers. So one has to be 4, the other has to be -4. So we're going to have to multiply each of those equations so that we can make the coefficients match. And I'm going to make the y, the coefficient in front of y, match. I want to make that equal to 12. So for the first equation, I'm going to have to multiply that by 3. So if I multiply everything in this equation by 3, I'll get 9x plus 12y equals -3. Don't forget to multiply the other side of the equality. The second equation, now I'm going to make that multiply by 4 because I want to have the coefficient -12 in front of y. So I'll get 16x minus 12y equals 28. Now when I add them together, I'm going to get 25x. The y's are going to be eliminated because they're opposites, equals 25. So x equals 1. Now that we know x equals 1, well, we could plug it into one of the equations. I'll just use the first one. 3x plus 4y equals -1. So 3 times 1 plus 4y equals -1. I'm going to solve for y. So I'll subtract 3 from both sides. We'll get -4. Divide both sides by 4 and get -1. So my answers are 1, -1, and I need to make sure I check that. So I'm going to use the second equation. 4x minus 3y equals 7. So 4 times 1 minus 3 times -1 equals 7. Well, that's 4 plus 3, and that does equal 7. So our answer is going to be 1, -1. Now let's go to the next example. Okay, for this one, we have 2x minus 3y. Let me just make sure I'm on the right one here. Okay, so 2x minus 3y equals 1. X plus 2y equals 3. Again, the coefficients are not matching, so it's going to be your choice how you want to eliminate. Well, I try to multiply at the least number of equations as possible. So when I look at the x, I can notice that this is just +1. So if I keep the first equation the same and multiply the second equation by -2, I'll eliminate the x. So we're going to add those together. So we get -7y equals 7, or y equals -1. Now I'm going to plug that back in to one of the equations. I'll just use the first one. So, well, I could use the second one because it has just an x. So x plus 2y equals -3. So x plus 2 times -1 equals -3. X minus 2 equals -3. 3. And when I when I add plus 2, I'll get negative 1. So this is going to be y equals negative 1 and x equals negative 1. Now I'm going to check that. So I plug it into the second equation. And so this one was the first one, 2x minus 3y equals 1. So 2 times negative 1 minus 3 times negative 1 equals 1. We'll have negative 2 plus 3, and that does equal 1. So our value, our coordinate, will be negative 1, negative 1. Now let's go to example 8. Now let's use elimination to solve word problems. The first one has an airplane and wind. So when we have an airplane, the airplane is going to be traveling at a certain rate. So you gotta have an airplane here, and it could be either going with the wind or it could be going against the wind. So we have two things happening here. We have the speed of the airplane, which I'm going to identify as x. So write down my variables, speed of the airplane. And my y will be the wind speed. Now when we consider speed, remember we're looking at rate. So we have to use the equation distance equals rate times time. So if we know the distance and the time, we can actually figure out the rate, because the rate would be the distance divided by the time. So we're looking at the rate of the airplane, the rate of the wind, and comparing the two, when it's going with the wind and when it's going against the wind. So when the plane's flying with the wind, it's going to go faster. So the speed of the airplane plus the speed of the wind will help it get to its destination. So when I look at those rates, we could add those speeds together to get the total speed. And when we look at the total speed, we're going to have to look at the distance that was covered, 1,000 miles, in 5 hours. So 1,000 miles over 5 hours means that together the airplane and the wind had a speed of 200. So I'm just going to erase this, and I'll put this over here so that, all right, with the wind was 1,000 over 5. So I'll put 200 right here. Against the wind, it's going to be going slower. It'll be the speed of the airplane minus the speed of the wind. And it said that if the plane could only fly 500 miles in the same amount of time. So its total rate was just 100. Now we have a system of equations that we can solve. You can see that the y's have opposite coefficients. One is 1, one is negative 1. So if we add them together, we'll get 2x equals 300. And we could solve for x. X will equal 150. So that means that the speed of the airplane was 150 miles per hour. When we look at the speed of the wind, we're going to have to plug that back in. So I'll use the first equation, x plus y equals 200. If the speed of the airplane was 150, then the speed of the wind must have been 50. So the speed of the airplane was 50 or 150 miles per hour. The speed of the wind was 50 miles per hour. Now before we get too far, remember we always want to make sure that we check our answers. So I'll plug it into the second equation, which was x minus y equals 100. And we know that this was 150. We know that the wind was 50, and it does equal 100. Now for the second example. Well, a lot of classes go to Six Flags and have field trips there. This year, the senior class at Princeton High School and at West Windsor South are planning their trips there. The senior class at Princeton filled 5 vans and 5 buses with 380 students. The senior class at West Windsor filled 16 vans and 8 buses with 752 students. If each van and each bus carried the same number of students, how many students will a van carry and how many students will a bus carry? So before we get started on writing our equations, we need to make sure we identify our variables. So we could say x is the number of passengers in the vans, and y could be the number in a bus. So let's first write the equation for Princeton. They had 5 vans, 5 buses, for a total of 380 students. West Windsor had 16 vans and 8 buses for 752 students. Now you may notice all of the coefficients, well, when we consider the x and y are different. So it's really your choice which one you want to eliminate. So I'm going to look at this y. So I'm going to have to multiply the first equation by 8. So we get 40x plus 40y equals, what's that number? 3,000. I don't need to put the comma here. 3,040. Now for the second equation, I'm going to multiply that by 5. So when we multiply that by 5, I should make it -5, right? So we could have a cancel. So I'm going to multiply this by -5. So we get negative 80x minus 40y. That's good because now the y's will cancel. Equals negative 3,760. Now when we add those together, we'll have negative 40x. The y's will be eliminated. Equals negative 720. Divide both sides by negative 40. And we'll have x equals 18. Now we can plug that back into the equation. So I'm going to use the first equation, which was 5x plus 5y equals 380. So that was 5 times 18 plus 5y equals 380. That was 90. If I subtract 90 from both sides, we'll get 5y equals 290. And divide both sides by 5, and we'll get y equals 58. So I have these two answers here. I have x equals 18 and y equals 58. Now I'm going to plug that into the second equation to make sure my answer works. We're for West Windsor. It was 16x plus 8y equals 752. So 16 times 18 plus 8 times 58 equals 752. That'll be 288 plus 464, and that does equal 752. So we could say right here, I'm going to actually write the answers down below because it's a little squished up there. that the number of that the vans will carry 18 passengers or 18 students, and the buses will carry have a little trouble writing here, carry 58 students. So remember, these are word problems, so we're going to make sure they have word answers. Well, thank you for spending time with me. I hope this video was helpful.